Welcome to the 8.4 warm-up. Number 1, draw a circle with a radius of 1.5 centimeters. You could have done this on a spare piece of paper, but I'm just going to do it right here. So a radius of 1.5 centimeters, I take my protractor, my compass, and set the two tips to be 1.5 centimeters apart. That creates my radius. Stick the tip onto the paper and then loop all the way around, and there's a circle with a radius of 1.5 centimeters. Now, what is the diameter of the circle? Diameter is equal to 2 times the radius, so 2 times 1.5 centimeters, so 3 centimeters. And if you take your ruler and measure through the center of that circle, it is in fact 3 centimeters for the diameter. Estimate the circumference of the circle. Well, circumference is pi times d. If we're estimating, then I'm going to use 3 for pi. My diameter, we said, was 3 centimeters. So once you do that multiplication, you're left with 9 centimeters. If you were to wrap a string all the way around the circle, it would be around 9 centimeters in length if you were to measure it on a ruler. Calculate the circumference of the circle, round to the nearest whole number. Okay, so in this case, we're not going to substitute 3 for pi, we're just going to use 3.14. Radius, or diameter, is still 3 centimeters, so we can leave that at that. And then when you multiply 3.14 times 3, you're going to be left with 9.42. And to the nearest whole number, that's going to actually be 9 centimeters. So our estimate and our calculation work out to be the same. Now, we've rounded down. This was very close to 9.5 centimeters, so it's off by a little bit, but it's a reasonable adjustment. Estimate the area of the circle. Well, now, area of a circle is calculated by pi times the radius squared, or r times r. So for estimating, we can use 3 for pi, and then multiply by the radius twice. So in this case, our radius was 1.5. I'm going to round that to 2. So I'm going to say that since I'm estimating, I'm going to multiply 3 times 2 times 2. Well, 2 times 2 is 4. Multiply that by 3, and we get 12 centimeters squared. So don't forget, units is centimeters squared when we're dealing with area. Now to calculate the actual area, we're going to see how close we get. So we're going to use 3.14 times radius, which was 1.5 centimeters, times radius again, 1.5 centimeters. So then when we multiply this out, we're getting 3.14 times 1.5 times 1.5, and we get an answer of 7.065 centimeters squared. Round your answer to the nearest tenth. Well, this is my tenth. My next digit is a 6, so I'm actually going to bump my 0 up to a 1, so 7.1 centimeters squared. Now, 7.1 and 12, they seem like they're not very close. 12 is not a very accurate estimate, but we did some rounding, and all 3 digits here are rounded. So when you're multiplying, when you're rounding, you have the possibility of really increasing the difference between your estimate and your calculation. So it's not like it's 1200 centimeters squared or 12,000. It's just 12. So 12 and 7 in the overall scheme of things are pretty close together, so I'm okay with that. Question number 2, change each percent to a decimal. And right here it reminds us how to do that. 12% 12% is the same as 12 divided by 100. And when you're dividing by 100, you take your decimal and you move it 2 spots to the left. So that leaves us with 0.12. So 12% is 0.12. 5%, move it over 2 spots, but there isn't a number here, so we're going to just fill it in with a 0. So our answer is 0.05. This one, 33, becomes 0.33. And here you can write 0.10, but you don't need to have the zeros on the end when it's to the right of the decimal point, so we can just say that it's 0.1. And that is fine. So list the numbers between 20 and 30 that are divisible by 3. Well, they're all divisible by 3, but evenly divisible, we have 21, 24, and 27. Now it says between, so I'm not going to include 30. 21, 24, and 27 is all that you need. If you wrote 30, you're correct, it is divisible by 3, but it's not between 20 and 30. It actually includes 30. So there's your warm-up.